guys, so there are these two conflicting parts of my brain right now. The first of which is saying, summer is ending, you go back to school on Wednesday, you need to get all your summer work done. And the other part of my brain that is saying, don't do anything. And of course, despite the fact that the first side of my brain is trying really hard, the second side here is clearly winning because I have not done anything today. That's not to say that I didn't learn anything. I learned a ton of really interesting things today, but none of them came from doing my summer work. I have a lot of work to be doing. I'm taking 5 APs next year, and I've completed the bridge work for 1 of them. Yes, that is true. But doing necessary work aside, today I spent my day learning about math. The only class that I already finished my assignment for, I spent the day researching. And not even calculus, because that's the course I'm taking next year, but arithmetic. So today I learned about something called the fundamental theorem of arithmetic. Essentially what this theorem states is that any whole number that exists in the entire realm of existing whole numbers must be able to be broken down into a unique set of prime factors. So at first I didn't totally understand what this meant because for some reason I was just not thinking about it properly, but what it means is that, like, 6, that's a pretty easy one, can be broken down into 3 and 2. Both 3 and 2 are prime, and therefore 6 is a real whole number. 100 is another example of a number that you've been told is a number. Is it really a number? Well, let's see. You can break it down into 5, 5, 2, and 2, because 5 times 5 is 25, and then 2 times 2 is 4, and then 4 times 25 is 100. And so, yes, 100 is a real number. You have not been lied to about that. But there is a problem that is presented when we talk about 1. The first problem that is presented is the concept of a unique set of prime numbers. And because anything times 1 is itself, having 1 as a prime number therefore makes it impossible to ever have a unique set of prime numbers. This is why 1 is not considered to be a prime number, by the way. Let's say that we're working with 6 again. We can break that down into 3 and 2, right? But if we make 1 a prime number, then we can break it down into 3 and 2 and 1, or 3 and 2 and 1 and 1 and 1 and 1 and 1 and 1 and 1, because no matter how many 1s we add, the value will not change. Therefore, there's no unique set of prime numbers that can be equated with 6. And that's why 1 is not a prime number. I hope that makes sense, because the next thing I'm about to say doesn't even make sense to me, because 1 is a number, right? We're all on the same page about that. We've worked with 1, we've added it to things and subtracted it from things, and it's never seemed to not be a real number. But when we use this fundamental theorem of arithmetic to define a number, it becomes kind of difficult to define 1. Because I don't know about you, but I can't think of any prime numbers that could multiply to be 1 if 1 is not considered to be a prime number. So essentially what happens is that there's something called the empty product, because there is no things that can multiply to 1. And for some reason that just fixes everything. I don't actually understand what it is, I don't know what that means, but empty product is the reason 1 is a number. Yeah. I learned about the fundamental theorem of arithmetic thing though, so I was going to share that. I just didn't know how to explain the 1 thing, because no one on the internet can make it make sense to me. So, if you understand why 1 is a number, you can comment down below. Otherwise, just the whole empty product thing will have to satisfy us all. Really just me. No one else really cares about this. Okay, well, mathematicians probably do. Alright, I'm gonna end this video now. Bye, guys.